Why can nothing travel faster than the speed of light? It appears to be a fundamental property of our universe that nothing can travel faster than the speed of light. This is the universal speed limit. Why light travels at this speed? The Higgs field is a quantum field that permeates all of space. Particle interactions with the Higgs field impart particles with their mass, which in turn slows them down. As particles of light, photons, don't interact at all with the Higgs field, they travel at their maximum possible speed, the speed of light. What happens when we try to accelerate a particle to the speed of light? When we attempt to accelerate particles to the speed of light, the closer and closer the particle gets to light speed, the more and more massive they become, until an infinite amount of energy would be required to accelerate the particle to light speed. And of course, we cannot provide infinite energy. Time dilation. It has been experimentally shown that the speed of light is the same for all observers. And taking this constant into account, Einstein revealed an amazing thing about the nature of time. It is not the same for everyone. Imagine a beam of light being reflected between two mirrors. Let's replicate this setup so we have another beam of light being reflected between another set of mirrors, but this time the mirrors are moving close to the speed of light. In the moving set of mirrors, the beam of light is moving a greater distance. Now place a couple of observers in this scenario. Meet Alex, who sits inside the moving set of mirrors, and Bill, who sits inside the stationary set of mirrors. The speed of light must be the same for both Alex and Bill, and their light beams must hit the bottom mirror after the same amount of time has passed. But as Alex's light beam is covering a longer distance, how is that possible? Well, the only way for that to work is if time for Alex slows down, which gives his light beam more time to travel a greater distance. Look at it this way. Speed equals distance divided by time. As the distance Alex's light beam travels is more, the value of his time must be more to keep the speed constant for all observers. Or rather, Alex's 1 minute actually turns out to be longer than Bill's 1 minute when you compare the two. And this is called time dilation. Time slows down for objects traveling close to the speed of light, and time stops altogether for objects traveling at the speed of light. Tachyons and the causality principle. We established before that particles cannot be accelerated to light speed, but that doesn't prevent hypothetical particles from already traveling at or faster than light speed. A tachyon is such a hypothetical particle that travels faster than light, and it would take an infinite amount of energy to slow a tachyon down. As time slows down for objects traveling close to the speed of light, time stops altogether for objects traveling at the speed of light. It then follows that time must go backward if objects travel faster than the speed of light. Tachyons, therefore, are also traveling back in time. However, most physicists do not believe in the existence of tachyons or the possibility of traveling back in time, as it would violate the causality principle, which states that an effect cannot come before its cause. Rather like how a bullet cannot hit a target before the trigger of the gun has even been pulled. Wormholes. Einstein preferred to think of space and time as one entity, space-time. One hypothetical proposition as to how we could travel between distant regions of space-time without faster than the speed of light technology is to use wormholes. Wormholes are theoretical tears in space-time that could act as shortcuts between distant regions in space. Exceptions to the rule. Stretching of the universe. Although it seems nothing can move faster than the speed of light in space, that does not preclude space itself from stretching faster than the speed of light. There are galaxies in the universe moving away from one another at a velocity greater than the speed of light. Quantum entanglement. Quantum entanglement describes how two particles can become connected in such a way that when the property of one particle is changed, an instantaneous change in the property of the other particle occurs. Entangled particles have the opposite properties to each other. So in theory, if a pair of entangled particles are separated by an entire universe, when the property of one particle is measured, the other particle on the other side of the universe will take on the opposite property. This seems to indicate faster than light communication between the pair of particles. Despite these exceptions, the assertion remains true that no particle can travel faster than the speed of light in space, and the reason is because this speed limit is a fundamental property of our universe. As always, I hope you enjoyed this video and please subscribe to London City Girl for more interesting and educational videos from me.